Hello, hey guys, welcome to Academy. Let's see, where are you all joining from? Hello everyone. I can see some familiar names. Thank you all for joining in. France, Idaho, Kentucky, awesome. London, perfect. Greetings from Italy. Hi Tiziano, Elena, Matthew, Carlos, Giacomo, Kemal, welcome again. Thanks for joining. Anshuman, Netherlands, Ecuador, saludos. Desde Chile también saludos. Ritesh, hi. Hi Guillermo. Okay, I think we are a lot of people. Awesome guys, thanks for joining in. We haven't done a live webinar for almost a year, a couple of months as well. We are really sorry for that. We were busy with classes, training, projects. So yeah, we are back with another webinar, and thank you all for joining in. Perfect. So meanwhile you are sharing where you are from, can you tell me where you're able to download the files? It's very important. I have also pinned a comment which will take you to the file. This is a temporary link, so after the webinar is finished, this link will not work. So anybody who's watching it afterwards, you won't be able to use that link. Just use your link in the Gmail to access the download files. Are you all able to hear me properly? My computer has fever and I have to turn on the fans at max. So let me know if you are hearing some fan noise in the background. I can reduce the volume a little bit. Okay, it seems like you can hear me properly. I can increase the volume a little bit if that's fine. Or are you able to hear the fan a lot? Okay, I think I'll leave it around there. Yeah, I hear background noise. Just I'll reduce a little bit. I think that's better. Yeah, I'll leave it there. Sorry guys, this is the computer. It's suffering a lot. I hope to get a new computer soon. Awesome. So yeah, where were we? So we have a lot of participants from everywhere, basically. And I can see a lot of people I have interacted earlier. Olivier also, thanks for joining. Nihar, Axel, Mosso, Brian, Tristan. Awesome, yeah, thank you very much for joining in. Great, so we will start just in a moment. I hope you were able to download the files. It's going to take you to a Google Drive folder, and once you unzip the files, you should be able to see these 4 files. Okay. All right. So with that said, we can get started. Sure. COS. Not the name is COS. Okay. You have the documents. Awesome. Well, it's good enough in my opinion. They're joining from blah. You'll be able to watch the video again after the webinar. Yes, you will be able to watch the video using the same link, just like our previous 6 webinars if you haven't watched them already. Okay, I think enough of chit chat. Let's get started. So let me quickly introduce myself. for anyone who's joining for the first time. I'm Aman, I'm from India, and I've been living in Spain for the past 10 years. And in these past 10 years, I've been using Rhino and Grasshopper as my primary CAD tool. And I help design teams create parametric textures on their products. So I've worked with BSH, Logitech, PA Consulting, and other companies to help them design certain textures on their products. And whatever I gain from doing these projects, I share with you guys over at Academy. So Academy is a live Rhino and Grasshopper training partner for you and your design team. So we founded Academy back in 2020. So my co-founder, she's also in the chat. She will help you with questions. Welcome, Estella. Huge shout out to Estella, if you can write in the chat. She has been working really hard to answer all your questions, queries, any questions you have about our courses. She's 24/7, talking with you guys. So really appreciate that, Estella. And yeah, so it's just two of us, and we have been running Academy for the past 4 years. So Academy is basically a live training partner for industrial designers specializing in Rhino and Grasshopper. So we help you learn how to use Rhino for industrial design projects like parametric modeling and texture creation. Okay. We also have some other courses. For example, Rhino course, which will help you create good models, or computational design course, which can help you create lattice structures or topology optimized geometries and machine learning workflows. All right, so we'll talk about our courses towards the end. You can check our Instagram handles. It's at Creative Mutation for mine and academy.xyz for our design school. So here you can see what I'm up to. I'm experimenting with these tools and creating interesting workflows, and you can check Academy to see what our students are up to. So we are really surprised by the talent that we see from our students when they submit a final project, and every time we are really surprised by the effort they put to explore these new tools and integrate in their workflow. So yeah, and you can also share your handle in the chat if you want to network with other fellow Rhino and Grasshopper users. So just to recap, I hope you were all able to download the files. If not, you can use the link that I have pinned to download the resource files. Okay. All right. So in this webinar, we will be 3D modeling this POC helmet. So the drill is just like before. We will start with Rhino. Okay, we will try to create single span curves and surfaces. We will use trim and join approach. Towards the end, we will convert this model into a solid model. And after that, we will use Grasshopper and import this solid model so that we can populate it with a voxel field and then replace the voxel field with a gyroid lattice structure. We will also see how you can thicken it and then how you can export it for 3D printing in STL format. Okay. After that, if you use Keyshot for rendering, we will import these helmet plus the gyroid structure, and I'll show you how you can do a cool reveal animation in Keyshot. Okay, so I hope everybody's ready. All right, so let's get started. So the first thing that we will do is open Rhino. I need you all to install 2 plugins. Okay, so let me open my Rhino environment. Just a moment. Okay, and we will head to the command bar and just type package manager. This is gonna pop up the package manager. Now these 2 plugins that I'm telling you is optional. You don't need it to follow the webinar, but it will be very useful if you want to quickly evaluate the continuity criteria of your surface, and later on when you're creating the lattice structure to smooth out the mesh object. So the first plugin that we will download is called Global Edge Continuity Tool. So just write global and you will be able to install it. Yes, the exercise can be done in Rhino 7 without any problem. I have exported the file for Rhino 6 as well. Let me know if you're not able to open the file. We have a lot of time, so I can export it again just in case. But I remember I exported in Rhino 6. Okay, so once you install the Global Edge Continuity tool, let's also look for another plugin called Weaverbird. Okay, so this is a plugin for Grasshopper. Okay, so let's press install as well. Alright, so once we have installed these two plugins, we need to restart Rhino. Alright, so that these plugins can load in the Rhino environment. So just close Rhino and then restart it. I have already installed, so I don't need to do that, but please go ahead and restart your Rhino environment. So we will use the Global Edge Continuity to check the continuity between surfaces, and then we will use Weaverbird to smooth out mesh objects. Okay, we will address the questions towards the end of the presentation. However, if you have some technical questions related to the exercise that we will be doing, just keep on writing them in the chat, and I will try my best to address these questions as we move across the different phases of the modeling exercise. All right, perfect. So I hope you were able to install the plugins and restart Rhino. Okay, perfect. So let me just quickly take you through the steps that we will take in Rhino. So I have created a 3D scan by taking a couple of pictures of an actual helmet. I have imported it in Rhino and cleaned the mesh a bit. And after that, I'm just using this mesh to create the primary curves. And the goal is to always create four-sided surface problem. Okay, so I will create 4 curves and use these 4 curves to create the surface. Okay, so we will use single span curves, which are kind of like the gold standard to create high quality surfaces, which then in turn will create single span surfaces. Okay, and every time we are dealing with a 3-sided problem, we will try to convert it into 4-sided problem. So here you can see, if I had to create a surface here, I had only 3 sides, one at the bottom, one in the arc, and the other side is here. So what I will do is create a new side here, and then I can convert this into a 4-sided problem. 1, 2, 3, and 4. Okay, so let's see how to execute this in Rhino. All right, perfect. So let's open our Rhino environment. Let's go to the download folder, and I'm just going to drag and drop this file in my Rhino environment, and I will open it. Okay, so this is the 3D scan. Okay, so you can go to the rendered viewport to see the 3D scan. All right, and the file tolerance that I'm using to model this helmet is 0.01 millimeter, 1/100th of a millimeter. So that is a good file tolerance for creating a draft model. If you feel challenged, you can change the file tolerance to 1/1000th of a millimeter, which is going to make this modeling experience a bit more challenging because you need to further refine these continuity criterias. Okay, but for now we are going to set it to 1/100th of a millimeter. Now for the next step, I have created multiple layers, and you can follow each and every step by unhiding these layers. So let's unhide the first layer, where we will see how to create our primary curves. Okay, perfect. So in order to create the primary curves, we are going to evaluate the 3D model, the 3D scan. I will extract the silhouette of the 3D scan from the right viewport. I will use a single span curve to capture that shape. Okay, I will recreate the curve from the top viewport, and then I will generate some cross-sectional curves. Okay, so let's see how we can do that. So let's go to the right viewport, and in order to extract a silhouette of any object in Rhino, there is a command. I'm just going to use a random shape to show you. There is a command called mesh. I think it's called mesh edge. If anyone knows the command. MeshOutline. Okay, I remember now. MeshOutline. I'm using different languages and sometimes I get confused. So MeshOutline will help you extract the silhouette of any object. All right. Thanks, Brian. So this is the silhouette, and now I'm going to create a curve between these 2 points. So in order to create a NURBS curve, let's use this command, control point curve. The minimum degree that we will use is a degree 2, which means we can create 3 points. Okay, so let's create a first point here, second point somewhere in here, and then the third point. Okay, so this is a single span degree 2 curves with 3 points. Single span basically means that it's a mathematically continuous curve. You can see the curvature continuity by analyzing the curvature graph. And this is going to create a really smooth curve, which is crucial to create high quality surface. Now you will notice that in this degree 2 curve, I'm unable to capture the shape properly because I only have access to 3 points, in which the first and the last point are used to anchor the curve, and I only have a third point to capture the shape. So what I can do is bump up the degree. Okay, so from degree 2, I can change the degree to degree 3. So in degree 3 curve, I will have 4 points. So you go to curve tools, change degree, set the degree to 3. So now you will see the curve remains the same, but we now have 1 more point, which we can then move. So let me move the curve here and there and try to capture the shape. I think I need 1 more degree to capture that part. So let me redo, change degree, set the degree to 4, which means we now have 5 control points. Okay, so I will be able to better capture the curvature. Okay, so I have already done this for you. So if you just scroll to the right side, okay, you can turn on the control points and then just snap these points to these anchor points. Okay, so this is the final position of the curve for the next step. Okay, perfect. So this is the final curve. Awesome. Now let's go to the next step, which is, so just a second, what I was using for scanning, I'm just using pictures and then an app to stitch it into a 3D model. MeshOutline, correct. MeshOutline not working, yeah, so the reason it's not working is that this is actually a block object. Okay, this is because I want to save space. And if you copy a block object multiple times, the size of the file remains the same. The only thing you need to do is explode it, and this is going to convert it back into a mesh, and then you can run MeshOutline. Okay, awesome. So once we have curve from the right viewport, let's recreate the curve from the top viewport. Okay, so I've already done the curve here, but let me just show you the same technique. I'll isolate the curve for a moment. I will start in a similar manner, degree 2 curve, start here, first, second, third point, curvature graph, okay, and I can move these points to see if I'm able to capture the shape. If not, I will bump up the degree to have one more control point and then try to capture the shape again. If not, I will change the degree, bump it up one more time, and I'm able to get that shape properly. Now, the last point is set where it should be, but the first point needs to be in the same height in y-axis. Okay? So there is a special command that we can use to position this point exactly at the same height in the y-axis. So the command is called set points. So transform set xyz coordinate, also known as set point, and we are going to set it in the y-axis. Okay, and now you can see the height of that point is exactly in the same line. Okay, so this is a very useful tool to align an object, especially a point, to a specific height. All right. What command do you use to add degree? The command is called change degree. Correct. Thanks for pointing it out. Okay. I really appreciate you guys if you are able to help each other, because as I'm moving through the exercise, I'm able to read some comments. But yeah, if you are able to reply with the correct commands, really appreciate it. Perfect. So once we have made the side viewport and the top viewport, we can now create some cross-section curves. So basically, I'm gonna convert this problem into four-sided problem by blending these two curves and then these two curves. Okay, so you can run the command blend curve. Okay, curve, adjustable blend curve. Curve 1, curve 2. And we are going for curvature continuity here on either side. Okay. And for this part, if I analyze the rendered viewport, you can see that the helmet, it's not creating a tangentially continuous surface here. There is like a sharp change in the direction. So we only need position continuity here, and on the top side we need tangential continuity. Okay, so at the moment I'm just gonna create a blend curve between this and this. On edge 2 we just need position, on at edge 1 we need tangency, and there is a reason for that. I'll explain you in a moment. So in order to further calibrate it, you can go to the front viewport, and here you can see the shape with respect to the 3D scan. Okay, so if you're unable to capture the shape, like before, select the curve, change degree, degree 3. So now you have one more point. I'm only gonna move this point freely because this point only needs to be moved in this tangent axis. Okay, because we want to make tangential continuity on the other side. So I'll move this curve around here. I'll change the degree one more time to degree 4. So we have one more control point now. Okay, I can capture the shape a bit further. All right, so once we have captured the shape, these are our final set of curves. Okay. Injection process is the parting line, and that's why the position probably, but sometimes it can also be just a design intent, okay, to make it look a bit more sporty, aerodynamic. So it could also be that case. Why increase the degree instead of making more points? So there is a concept called single and multiple span curve. So let's say if you create a degree 2 curve and you create 3 points, until third point it's a single span curve. The moment you add more points, instead of a spline, now it's a non-uniform rational Bezier spline, which means there are multiple spans within the curve. So mathematically this curve is not that smooth. Okay, so this is the reason we create a single span curve and change the degree while still maintaining a single span profile but having more control points. Okay, perfect. Now for the next step, let's unlock the next layer. Primary curves. So I will read you the steps. We will first create a four-sided problem. We will trim these curves into 4 pieces. Then we will create a surface. After that, we will match the surface for tangency. And then we will convert these 3-sided problem. As you can see, we only have 3 sides into a 4-sided problem. Ensure we have tangency and curvature continuity. And then towards the end, we will model the bottom section. Okay, so let's see how we can do it. Steps. So the first step is to trim these curves, or split these curves into 4 pieces. So we will split this with that. You will also notice that I am moving these curves exactly by 400 units. This way I have a physical timeline. So if I want to recover any geometry, I can just create a copy and move it by -400 or +400. Right. So once you create these 4 curves, now let's convert it into a surface. Now there are different ways we can create a surface. So you might say, let's use surface by sweeping 2 rails. Rail 1, rail 2, section, section, run. Okay. If you have changed the backface setting, you might see the magenta side on this side or the opposite side. If you see that, you can just flip the surface. Okay, it's just changing the normal direction. Anyways, so as you can see here, if I turn on the control points, a sweep command distributes the control point in a non-uniform manner, as you can see here. Okay, so this is not that great for creating high quality surface. A better way to generate a surface here is using this command, which creates surface from 4 or 3 edges. 1, 2, 3, 4. Okay, and if I show you the control points, you can see the difference between the 2 commands, right? Perfect. So this is how we will model this surface. Now for the next step, you can zoom into this section. We need to make sure that there is tangential continuity between these 2 surfaces. Now you might wonder, why are we aiming for tangential continuity? Okay, so anyone who is interested in learning Class A modeling, I highly recommend you all to check these golden rules that you can find in Alias webpage. So you can read through all of these different rules, and they will really help you understand how to create high quality surface model. So one of these rules is called ensure tangency across the center line. Okay, let me explain you why. If I create a curve and ensure tangency just by using 2 points, and another curve where I ensure curvature by positioning 3 curves, let me show you in curvature graph what happens. Okay, when I mirror it, because it's a symmetrical shape. When I mirror this curve, can you see that exactly at the center where the symmetry line is, you get a 0 curvature zone, which means your surface will become flat for a very small fraction of a surface. On the other side, if I mirror this shape, you can see the height of the 2 curvature graphs are the same, which means we have curvature continuity, but we don't flatten out the surface. So how this translates into an actual surface, let me show you. So if I extrude it, okay, and I'll show you using zebra. Can you see here? Just a moment, because I'm using an isometric viewport, so it's a bit difficult for me to show you. Let me change it to perspective just for a second. Now, can you see it here? This is the curvature continuity in symmetry. This is the tangential continuity in symmetry. So you can see in curvature continuity, you create a very small flat section, whereas here you translate from one side to the other in a very smooth manner. Okay, perfect. So that is the reason we will ensure tangency on the symmetry line. So let me zoom in here. So in order to ensure tangency, let me use zebra so that I can show you the effect. You will run the command match surface. You will match this edge to the other edge. So you have position, tangency, curvature. We are not aiming for curvature, we are aiming for tangency. Okay, the other settings are set to default, none. You can also copy these values. Okay, and we are going to match the curvature isocurve to this flat surface. So now when I mirror this surface, you can see we have really nice continuity between the two surfaces. You can also use EMAP to see the effect. Okay, perfect. I'm also using another command called move UVN to further calibrate the surface. So if you turn on the control points, you can run a command called move UVN, and then you can move these control points in the normal direction. I'm using this to further capture the shape of the helmet where we didn't have a lot of information. Okay, so once I have mapped it, this is the end result. I will further match the tangency continuity just to make sure, and this is the end result. Okay, surface as a setting, display mode. Yeah, you have to change it in document properties, view, display mode, shaded, object, surface, and then you can define one color for U, one color for V. Also remember V for vegan, vegetarian, that's why it's green in color. Okay, all right. So now we are ending up with a three-sided problem, as you can see. 1, 2, 3. So in order to create a single span NURBS surface, we cannot work with 3 sides. We need to convert this into a 4-sided problem. So the way we can do this is by creating a sphere at this point. Let's say 25.5. You can test a couple of different radius, and then you intersect these two surfaces. So you will get this curve. Now I will extract the isocurves of the surface at these 2 points. So run the command extract isocurve, extract it here, and then rerun the command, but this time change the direction. Okay, so now we have extracted the 2 isocurves. So you can go to the next section. Now we can split this curve with this one. Okay, and then we can split this curve with this one. All right, so we can delete the axis curves. Now I can blend this curve to this curve. So run the command blend curve. We are aiming for curvature continuity. Press OK. So that's how we are able to get the 4th side. Okay, so you can zoom into this section. Now we will split the surface using this and this curve. And this way I can get rid of this part. You can also delete the curve. Okay, now the only thing that you have to remember here is that the curve that you need in this section, you have to go all the way back where the curve was intact and bring it back to this section. Okay, so what you can do is just drag this curve until here and see more or less it's around 4,000 millimeters. So I can just copy it by 4,000 units. So it will exactly position itself there. Okay, you can further tweak it. If not, you can also do this. You can try blending this edge to this curve, okay, to match the shape of the curve more or less in a similar manner. Okay, so I have already done that here for you. So you can see we have curve 1, curve 2, curve 3, curve 4. Just like before, we are going to create a surface using these 4 curves. Let's flip it. Okay. And we are also going to extrude this curve to resolve for symmetry. So I have already made the surfaces in this section. Okay. Now this is where we will start to use the global edge continuity tool. So let's select all the surface and run the command global edge continuity. So this is going to pop up a display. Now if you're running the command for the first time, there are a couple of things that you need to change. So you can see the colors for G0 fail, which means the surfaces are not connected at all. You will see a red edge. For position, you will see gray. For tangency, you will see blue. And for curvature, I think the default is set to white, but personally I set it to green color. Okay, so you can change that. Now if you're unable to see some of these continuity criterias, it's because by default the only edges that you're evaluating is G0. So that is why you are not able to see green, so curvature or tangency. So you want to evaluate tangency as well as curvature. So let's set it to G2. Okay, perfect. So now we are going to match the continuity. Also make sure you're using these same numbers in the evaluation command. So 1/100th of a millimeter for position continuity, 1/10 of a degree for tangency, and 1/10 of a curvature. Okay, that's the tolerance we are working with. So now I'm going to match this surface to this surface in tangency, so that when we mirror it we get curvature. And you can see this edge at the moment is G0 because it's gray in color. So let's run match surface command, match this edge to the other edge. We are only aiming for tangency, and we will make sure that the surface matches its isocurve direction to that surface. You can see I'm using a similar values here. Just copy the same numbers so that you are matching and evaluating using the same numbers to get the correct output. Press OK. So now, can you see we now have a blue edge, which means we have tangential continuity here. We are going to do the same thing in this edge. We have only position, so let's run match surface, match this with that. We are first aiming for tangency, and you can see we are able to match for tangency. And when we match it for tangency, we automatically get curvature. Can you see that? We automatically get curvature. So it's green in color. Now the last thing that we are left to do is match this edge to that trimmed edge. Okay? So when you're dealing with a trimmed edge, you can see that trimmed edge is made out of a curve which is not a simple curve, the one that we blended. Okay, so in order for this edge to match that shape, we might have to add more control points. Okay, so let's see how we can do that. Let me go back. So now let's run the match surface command, but before that I will turn on the control points so that you can see what's happening with the control points. Match surface, match this to that, and you will notice that if I'm trying to match it as it is, the control points are just flying everywhere. That is because it's trying to match the topology of the two edges, which is not the same. So what we can do is just try to pull the control points to the closest edge possible. So let's select this option. Okay, so now you can see it's a bit better. Apart from that, we cannot ask the surface to match for the isocurve direction because these two surfaces are fundamentally different. So we will ask it to preserve its original isocurve direction. So now you can see it looks a bit better. Let's press OK, and you can see that when I try to match it, it didn't match. Furthermore, it detached the other edges. So let me undo it. Now, instead of trying to match it with 6 control points, I will change the degree. So in the red axis, the U axis, I will add more control points. Change degree. So instead of 5, what if I use 7? Okay, so let's try to match now. Just like before, tangency, match by closest, preserve isocurve. So as you can see now, as I matched it, it was able to match. Let me try to rematch this edge. Let's see if we have luck. Okay, so I was able to rematch this edge. So I have already done this for you guys. You can check it here. Let's close it and rerun the command. Okay, I think I have done it here. Just a moment. All right, there you go. So here you have curvature, curvature, tangency on the symmetry line. Now for the bottom section, I'm just duplicating the edge. I'm scaling it and then moving it down. Okay, and then we can loft these two curves to create a simple surface. Okay, so once we have that surface, I will also correct the edge. So you can just turn on the control points, duplicate the edge, make sure it's aligned to this axis in the X direction, and use that curve to maintain a symmetry line. So match surface, match this with this, tangency. And then the rest is just trying to capture the shape. I'm also moving the 3D scan between phases so that I can easily see what's happening here. For example, let me move back the 3D scan. If I turn on the control points, I only have 2 points, so I won't be able to capture this curved shape. So let me change the degree to degree 2 for the V axis. So now you can see we have one more set of control points. So I can move these points manually so that we are able to capture that shape. Okay. Of course, try to distribute the points in a manner where you're not exaggerating the movement of the points. Okay, so I'm trying to create like a uniform distribution of the points. So if I'm stretching it too much, I'm just moving it back. Maybe I have to rethink by adding more degrees and trying to capture it in a better manner. So that is the end result. So with all of these, what we are left with, let me rerun global edge continuity, is tangency, tangency, sorry, curvature, curvature, position, you can delete everything except these 3 surfaces, and then we can mirror it. Okay, so if I show you an EMAP, this is the end result. Okay, let's unlink or unhide the next layer. So now we are going to trim the excess parts. So we are going to draw the profiles. Okay, split it. We will connect the front part here. Then we will match the surface. We will then trim the excess part from the bottom. Okay, and then we will convert it into a solid model at the end. So let's see how we can do that. Let's go to the right viewport. Okay, you can use this button to zoom into that selected object. So I'm creating these curves using reference image or reference 3D model. Okay, then I'm extruding it and using this curve and projecting it here. So you can also run intersect or project to get that curve. Okay. Now I will split the surface with that curve. Okay, I also created another curve here, and I'm going to create a surface around this area. So I'm breaking this surface by splitting it on these isocurve around here. Okay, you can use the reference 3D scan to see until where we need that part. So I think until here it was fine for that surface to continue and attach here. Okay, so I'm breaking it around this part. So I have this edge, which I can then blend with that edge. Okay, so you can run blend surface, blend this to that. So let's use the lowest one, tangency, press OK. Right, and then in order to connect this with that trimmed edge, I'm rebuilding this surface with a lot of control points. So I think I'm rebuilding it with 24 control points. For degree 3 and 3. Okay, you can flip it, and now we can match this edge to that edge. Match surface, position, we just need a position continuity, match by closest. Okay, because it's a trimmed edge, so whenever you're trying to match a trimmed edge, you always use the closest option. Okay, and we are going to preserve the isocurve direction. Press OK, and now if we are able to join it, we can show edges to see if we have any naked edge. That's great, there are no naked edges. Okay, so this is what we end up with. You will also notice that here you won't see these isocurves, because in Rhino we have a setting where we can disable the preview of the isocurves. Okay, now lastly I have this other curve which we can extrude and then use this extrusion to split the part into 2 pieces. Okay, that's the end result. And in order to create the internal section, I'm just copying and scaling it by 0.8 units in the center, like that. Then I'm duplicating the edges, join it, redo the duplicating the edges, join it, and then we can loft these 2 curves so that we can stitch it as a solid model. Okay, now this part is very concave, so what I can do is further extrude it and then use that surface for Boolean difference. This is just to get a bit more space in this axis. Why do we not offset the surface? You can technically offset it as well. It's just that if you offset this poly surface, let me show you. Surface tools, offset. Let's say if I offset it by -10, just a moment, why is it not offset? Flip all, yeah, 10, sorry. You don't set it -10, you flip the normal direction. Okay, and convert it into a solid model. Yes, technically it works, but you can see now if I show you the ISO curves of that offsetted part, it's going to be made out of way more complex surface. Not bad, but now if you see, we have a similar topology outside and inside. Okay, this is just to keep the surface quality cleaner on the inside. So this is the end result. Okay, we will just join everything together as a single solid model. All right, now let's go to the layers, layer number 4. Now in this layer, we will create the cut holes. Let's go to the right viewport. We are then copying the shapes. Okay, so we will first get rid of the axis parts. Okay, if you know, there is also a tool called curve boolean which you can use. So it will automatically give you the intersecting curves. Okay, I'm creating a couple of additional curves and then I'm filleting the corners. Okay, to get these shapes. I'm also then creating these lines and extruding in, expanding them so that I can create the internal cutout section which will go through the helmet, and then an outer cutout section which will only be superficial cutout. Okay, and you can do that just by offsetting the curve. So I'm offsetting this curve by I think 2 millimeters. So this is the end result. And finally fillet these corners. Okay. Ever an issue that you are working far from Rhino's origin now? No, there's not such an issue if you're far from Rhino. Just make sure that you select the geometry and use this option to zoom selected, which will reset the camera center to this selected object. As a reference, making these curves that you mentioned, what is the most accurate way to possible apart from referencing with the eye? The direction is wrong. Why not offset? Oh, okay. All right, I'll address these questions just in a moment. All right, so the last part is just taking the helmet and I'm exploding it and just using the top surfaces and moving it sideways. Okay, so I will project this thing here and then the smaller one on the smaller surface. So we can do this here. Let's go to the right viewport. Project the bigger one to the outer surface and then the smaller one to the internal surface. Okay, so as you can see here, we now have these two curves and we can split the surface using this curve, this one with this curve, and you can create the hole and finally loft it to connect the two sides and join it all together. Okay, so that's what I have done here. Then in order to create these cutout shapes, we will project these and these. So I will split this from here and we will offset these by -5. So that we can then use this solid to remove the material from the helmet. And I will offset these by -50, so that it goes through the complete helmet for the vent. Right, so these are the 3 shapes we need for the perforations on the lateral side. Now we have a couple of perforations on the top side as well. Why not we rebuild the projected curve before split? No, when you project a curve on the surface, this is something that we call COS, curve on surface. When you rebuild it, it will actually not be on the surface anymore, and you won't be able to use it to cut the surface. Okay, so you cannot rebuild a projected curve and use it to split the surface. Alright, so for creating the top shapes, let me zoom in here. Okay, unlock this layer. So from the top viewport, in the rendered mode, you can see I created the reference curves, created these additional curves. So you will first get rid of these intermediate sections, which you can also do by curve boolean. And then you will fillet the corners. You also need the combined curve. Which you can also get from curve boolean, apply fillet. And then what I'm doing is creating a curve boolean of this and offsetting it. This is to get that thinner offset, and then these 3 are gonna be the complete offset going through the helmet. Okay. Similarly, I make the curves for the lateral vent, the one in between, in a similar manner. Okay, so these are the curves that we need for the next step. So we project these 3 curves on the surface. We project the outer curve to the surface. Similarly, these 3 curves and the outer curve to the surface. That's what we have here. I will split the surface using these curves. So we have these superficial offsets, and then we will split the surface with these internal curves, which will perforate through the helmet completely. Okay, so these are the curves, as you can see. This will be offsetted only by 5 millimeters. And then these will be offsetted by 50 millimeters. So that it goes through the helmet completely. So these are the shapes. Let's unlock 6th layer. Okay, so as you can see, we have a lot of geometry in the Rhino world. So just select the Boolean objects and zoom in to that part. So what I'm going to do here is mirror the shapes, subtract first the surface level, then the complete through, and then the lateral parts. Okay, so I'm also color coding it, so that it's easy for you to see which are the steps. Okay, so these are the perforations that go through the shape completely. Anyway, so these are the shapes. I'm also intersecting the helmet by moving it by the multiple of 400 units. So let's try this here. Boolean difference. Remove from the solid using the cyan surface level offset. So as you can see here, we are able to cut these perforations. Next step, Boolean difference, but now with these blue perforations which go through the helmet completely. Okay, I'm also doing the same thing with the bottom curve. Select it, split it, and then use that split surface to offset it. And then Boolean difference. Okay, so that is the final output. Now the last thing that's left to do is create the vent cutout from the backside. Let's unlock 7th layer. So we are going to draw the curves from right viewport. Then we will project the curve onto the geometry. Okay, intersect this one with the outer one, this one with the internal one, and then trim out the excess parts. Then we will loft this with this, and the top one with the top one. I will also rebuild the lofted surface. Let me show you what I did here. So if I loft it, you can see that the surface that you get from the loft might have the isocurve distribution in a random manner. So by rebuilding it by, let's say, 60 points, okay, I'm redistributing the control points, and it's gonna give me a cleaner output. Okay, so let me join everything together so that we have a solid geometry. At last, we can apply fillet on these corners. So that's how I'm going to apply a fillet here of 5 units. So you can see it does work, but here it's creating an open edge. So what you can also do is create a fillet, and you can set the radius of this handle to 0 units. So what it will do is create a fillet where the rolling ball will basically converge into a single point. So you get this nice rounded fading effect to a sharp corner. So I've already done that here. Okay, so we are almost done. This is the final output. I'm also adding some additional fillets on these corners just to make it rounded. So let's unlock the next layer called the final, and this is the final assembly. I've added the belts and the buckles as well. Right, so some questions. Average issue, okay, while taking a 3D model, 3 Natium, can you explain a bit more? What are you trying to ask in this question? Why did we not rebuild the projected curve? Yeah, I explained that as well. Does the surface reconstruction not affect the edge for the joining? A good question. So when I lofted it and then I rebuild the surface, it does affect, but this is where we use the file tolerance. So when I loft these two surfaces and I rebuild it using, let's say, only 5 control points, of course the edges of the new surface and the edge of the old surface will not join together, as you can see. So this is the reason we were rebuilding it with not 5 points or 20 points, but rather 60 points. Okay, you have to do some tests to see whether 60 points is able to join the surface in a watertight manner or not. You can also start with lower number, try to join it. If it doesn't work, increase the number to 40, try to see if it works. If not, then increase the number to 50 or 60 and redo the operations. So that is why we are rebuilding it with more number of control points. It's able to capture that shape within 1/100th of a millimeter. When you are drawing curves while taking the 3D scan as a reference, the curves to make the whole in general outline, what's the best way we can make those curves made? I mean, you start from the typical front, side, top viewport, and then you can move them. I generally prefer to keep the curves planar rather than working with 3D curves. Okay, it's easier, it creates cleaner iso curves, and later on when you're trying to match continuity, it also gives you better output. Why didn't you loft the top bottom together on the back side? Why didn't you loft the top and the bottom together on the back hole? You mean these or these? Because in the model we have the cutout shape. Okay. Of course, there are more details we can add, but I'm stopping with the details here. Okay. Perfect. So once we are done, how can I compare the mesh and the CAD file? Good question. So there is a way you can actually do the comparison. Let me move this object by 3600 units. Okay. And there is a command which is called point deviation. Okay, point deviation. I'll show you using a simple surface. So let's say we have a surface here, and let me create another surface, and let me deviate it slightly. Okay, so the command point deviation, select object 1, object 2, and press enter. And this is going to tell you by how much these two shapes are deviating from each other. So you can do this here, point deviation. We have to first explode it because it's a block object. All right, so point deviation between this and the outer helmet. It can take a while because it's a complex shape. But yeah, here you can see by how much you are deviating from the original model. I think an easier example would be in the starting phase when we were trying to capture this shape. So point deviation between this and the helmet. Okay, so here you can see the deviation amount. Okay. All right, so let me go to the last layer, the final layer. Okay, so here we will see how to add the gyroid structure. For that, let's go to Grasshopper. You can launch Grasshopper by pressing this button or running the Grasshopper command. It's gonna pop up this window. So it's like an interface on top of Rhino where you can create parametric modeling by connecting these different nodes together. I will extend the viewport until here so that we are not hiding anything behind the Grasshopper interface. All right, now for this next step, rather than starting from scratch, I have also prepared a file for you. So this is the second file. You just have to drag and drop it here. It's going to take a couple of seconds, and you should be able to see these nodes. Okay. If you see some error, just try to ignore it and then see if you're still able to see some things on the canvas. So let me take you through the steps. I'm importing this poly surface inside Grasshopper. Let me hide it. I'm converting it into mesh. Okay, by converting it into mesh, it's easier later on to split the lattice structure with the boundary. So let's connect the mesh to the geometry input to create a voxel lattice. The orientation of these voxels are going to be X and Y plane of Rhino. The size of each voxel box is 20 by 20 by 20. And you will notice that it already created these cubes of 20 by 20 by 20. Okay. And then do you want to fill this 3D model completely with these voxels? Let's connect it here. True. Okay. So I'll wait for you guys to open the file and let me know if you're able to at least connect these cables. how can I compare? It's a big deviation. Yes, it is a big deviation because we are just, learning how to create surfaces. You can, of course, further fine tune it based on the initial curves, but it's just to give you a general overview on how to model a helmet. What's the best tool that you used that use it to make any texture on freeform body? The best tools, so we generally use a combination of Grasshopper and Rhino. So Grasshopper to generate the texture and Rhino to transfer the texture to the actual model. Okay. Right, so are you guys able to create the initial part of the Grasshopper script? Please let me know in the chat. Only one half. Yep, it is working well till now. Okay, great. So yeah, I have made the file in such a manner that you just drag and drop and you're able to at least see the end result. Now what I will do, do you ever build the base geometry in SolidWorks and then transfer it into Rhino and then Grasshopper? Yes. Just think of this polysurface as if you imported a step file from Fusion or from SolidWorks or from Alias. You can literally import it in Grasshopper and then follow the next steps, just like here. Right, so once we have populated the volume with these voxel fields, I'm going to create gyroid lattices, okay, on these voxel fields. So you just need to connect the voxels to the voxel input. Now you can see we are populating the helmet with these gyroid structures. If you have never used Grasshopper, what you can do is just select the nodes, middle mouse button, and you will see this blindfolded man. You will use that to hide the previous steps. Okay, let's hide it. Now what I will do is use the mesh to trim out all the access lattice that we are overbuilding. So that is the next step. Trim access lattice. Connect the mesh to the geometry input here. And that is gonna get rid of the access lattice. Now of course I'm using a bigger voxel size because I didn't know like how strong or how powerful your computer is, but you can double click this number and change it to 15. Okay, it's gonna create denser lattice, or even 10. So once you have made these lattice, you can then thicken it. Okay, you can change the distance. You can double click and write, let's say 2.5. So for those of you who are unable to see the mesh edges, there is a setting here in display, preview mesh edge. You can also press Control or Command M for mesh. Okay. You can change the number slider to a different thickness. Okay. The way you create these number sliders is just by double clicking and writing a number. Alright, so I've already set it to 2 millimeters. And finally, these are jagged meshes, so I'm going to smooth it out using a Catmull-Clark subdivision algorithm. So that is the final output. You can press Ctrl M to hide the mesh edges and you will be able to see it properly. Okay. If you're unable to recreate it, don't worry, you can just go to the bottom of the script. I have already made these connections. You just have to press the middle mouse button and enable all of these nodes. Again, that is going to show you the output. So finally, in order to convert these mesh objects into a Rhino object, you have to bake the output. Okay, so you right click on the last node, press bake. You can bake it in default layer, press OK. So now you will see the mesh object in Rhino. So you can now export it as step or STL file for 3D printing. Why do we transfer the file as a mesh object? Sometimes the NURBS surface boundary it creates a more complex output, and some of these plugins struggle to capture that continuous surface. So by converting it into mesh, you convert that infinitely smooth surface into a finite polygonal geometry, which makes it easier for the script within it to split the gyroid lattice with the outer mesh. Okay, so that is the reason I'm converting it into mesh. I always try to do it directly, but if it doesn't work, I convert it first into a mesh and then it works better. Awesome. All right, so once you bake it, you are able to see the output, and then you go to layers and you unlock the last layer called render. So this is a combination of all of these different elements that we have modeled. So as you can see here, we have the belts, the helmet, and then the gyroid structure. Also, the helmet, I have split it into 2 pieces, okay, so that we can create some interesting animation in Keyshot. Okay, how could the density of the lattice structure be varied using color graph? There are ways we can do it, but it will take a bit more time to create that script. But yes, it is possible. I'll show you some reference projects where I have done similar thing. Your mesh thicken won't work. Don't know why. It should work. At least try to enable the script at the bottom of the Grasshopper file and see if it's working there or not. If it's not working there as well, there might be some issue with your plugin or your version of Rhino. Alright, so once you have created these files, we will export it as a Rhino file, okay, which I have already done, okay, in the download folder. Now for the next step, we will open Keyshot. So if you are using Keyshot 2023 or 2024, you can just double click this file. It's gonna launch Keyshot, okay, and let's see. Yeah, so as we are opening a package file, we have to extract the resources. So we will extract it maybe a specific folder or just the Keyshot resource folder. Generally, we'll use Keyshot resource folder. It's going to take a couple of seconds, and you should be able to see the helmet in Keyshot. Okay, I'm using the default workspace. We don't need the lateral side, so I'm just going to close the window and just extend this a bit more. Okay, so as you can see, this is the helmet. We have the belts, we have the helmet, and then the gyroid structure. In the helmet tab, you also have 2 halves. One is this one, and this is the other side. Okay, now apart from that, I have also added an animation, and this animation basically rotates the part from here to here. Okay, so the animation that we are aiming for now is making the part invisible as we move along the timeline. Okay, so the part that we will make invisible is this one. So in order to add an animation to that part, right click on it, add animation, fade. We are going to fade that part. And as you can see, we are fading it Keyshot should really work on the way these different tabs work with each other, because it's a chaos. But anyways, it's gonna fade from 100% to 0%. So as you can see, when we move in the timeline, we are able to fade the material's transparency to 0% and reveal the lattice behind it. Are you all able to try it out if you are using Keyshot? My question might be dumb, but what's the point of gyroid structure? I mean, in order to absorb the impact, so you can fill the lattice, 3D print it inside of the shell part. There are many artifacts here. It cannot be 3D printed. It can be, depending upon which slicer you use. So there are inbuilt tools in Bumble Lab which you can use to clean the mesh. There is a mesh repair command in Rhino which you can also use, but generally what we use is Dendro plugin. So Dendro is gonna convert it into a volumetric problem, and then we will fuse it all together in a smooth manner. Okay. Alright, so with that said, we are going to stop here with the Keyshot part. Okay, so if you have more questions, please let me know. Let's see. How to tell for Keyshot that I want to rotate the part. Again, select the part that you would like to rotate. Right click, add animation, and then rotation. You can also add these animations from the timeline, animation wizard, and then you can choose different animation types. Select the parts that you would like to animate. Next, and then you can add the animation. Okay. What's the name of the plugin you mentioned? Dendro, correct. So in Grasshopper, you have this plugin called Dendro. So you can use Dendro to convert these into volume objects. I'm running Keyshot in the background, that's why it's very slow. Let me close it. And now you can see this is a single volume object, and I can add smooth operations on top to further refine it. Okay, I have to change the voxel size to further calibrate it, but yeah, we will use Dendro to finalize the additional steps. Okay. All right. Between the crystalline and populating voxel, can you play along with this lattice? Yes, there are ways you can do this. I didn't want you guys to install a new plugin because it would have taken a lot more time. That's why I included the components. But if you have the Crystallon plugin, you can further add additional steps in between. So you can maybe, instead of using shell fill, you can use lattice fill. So this is the voxel, and you can change the lattice type to, let's say, a BC lattice. Okay, so I can then convert these into beams using multi-pipe. Someone is asking, are there other 3D geometric shapes beside the gyroid? Yes. In the Crystallon plugin, you have a big list of different lattice shapes, and you can choose one of these options. Model is choppy looking when it's for far origin. How do you manage this? Yeah, so there are certain bugs in Rhino. So as you can see, it's looking a bit choppy when you rotate the camera. So one option is going to document properties using the mesh setting and use smooth and slower option. Okay. If it's not enough, you can further increase the resolution. Wanted to know if it was possible to animate like a cross-section view of the inside of lattice that I can do on Keyshot. Yes. Crystallon only on Windows, or it can work on Mac? It can work on Mac. Under render, you can go to the pause real-time render. Yes, I can do that. Yeah, you can press the pause button. Could the density of the lattice structure be varied using color chart? That is a bit more advanced, but you can check our Instagram handle, and here is a post where we basically reduced the thickness of the lattice. Okay, and you can of course use a tractor to control by how much you want to reduce it. So we cover these topics in our computational design workshop. So this is one of our computational design workshop screen capture, and you can see we see how to control the thickness of the lattice based on a tractor geometry. Possible to animate cross-section? Sure. Cube affect the outcome? No, the voxel is always going to be cubical. To find multipipe, yeah, multipipe it should be in Rhino 7 as well. Make sure you're in the latest version of Rhino 7. How do animation of the texture? Is it possible to show a small preview of how it's done? Yeah, as I explained to you earlier. Okay, so let me just show you one last thing in Keyshot, and then I'll wrap it up. So if you'd like to create this cross-section view, okay, let me hide the helmet. So what you can do is create a cube. Okay, and assign this cube a material called Cutaway. And then you can move this object through the helmet, and you can cut the shape. Okay, so the object type is called Cutaway. There are some small mesh fragments which probably we need to repair it before I could apply this effect. But anyways, that's how you can create a cutaway cross section. You can do a similar thing in Rhino as well. So in Rhino, let's say you would like to create that cross section, you can run a command called clipping plane. And here you can see you're able to create a cross-section profile. Okay. Grasshopper course you just showed. I might have mentioned earlier, but where will this video be available after the webinar? In the same YouTube link. Okay, we will send an email for a recap, so don't worry about that. Anyways, so let me explain you a couple of things, and if you have further doubts, don't worry, I'll stay a bit longer. Alright, so first of all, thank you all for joining, and we will really appreciate if you can create your own variations of these helmets, lattice structures, renders, and share it with us on our social media platforms. So you can tag us, and we will of course share it with our design community as well. Okay, now apart from that, let me just quickly take you through what you can learn at Academy. Okay, so in total we offer 5 different courses. So the first 3 courses are Rhino Masterclass, Grasshopper Masterclass, and Keyshot Masterclass. They are ideal for beginner and intermediate users. So if you have never used these tools, or you have used it a couple of times but you are still not that experienced, you can join our Foundation Masterclass. Then we have the 2 advanced courses. Okay, so the Advanced Parametric Texture Workshop and the Computational Design Workshop. In these 2 courses, you do need experience in Grasshopper because it's an advanced course. We will be using advanced list operations in Grasshopper, so you do need experience. Okay, you can maybe join the Grasshopper Masterclass and then these 2 courses. Okay, we also offer training for teams. So if you work in a design team, you don't want to learn on our weekend courses, so we can create special groups for your team during the weekday, and we can also create bespoke training for specific workflows. So let's say you would like to learn how to create textures on mouse. You would like to learn how to create a design for manufacturing perforation holes on let's say air purifier. So we can curate special curriculum for your design team to tackle those problems. Okay, you can also check our web page, portfolio section, to see projects from our past students. Okay, so these are projects from Rhino Masterclass, Texture Workshop, Grasshopper Masterclass, Keyshot, and Computational Design Workshop. Okay, you can find additional information of our courses on our webpage. So in Rhino, you will learn surface and solid modeling, NURBS topology, foundations of Class A modeling, sub-D modeling, and some design for manufacturing criteria. In Grasshopper Masterclass, you will start from the very basics, learn how to connect cables. Then we will slowly learn how to create Boolean operations, and then list operations like flatten, graph, data hierarchy. And we will conclude by learning attractor workflows. Then we also have the Texture Workshop. So this is an advanced course, and here you will learn how to create parametric textures on products. Now these textures are NURBS textures, which mean they are ready for manufacturing. They're not like mesh displacement texture which you make in Keyshot. And you will see different strategies. In total we have around 14 exercises that vastly covers most of the type of textures you can create. And lastly, we have the Computational Design Workshop. So in this one, you will learn different computational design strategies like optimizing geometry topologically, machine learning workflows, lattice structures. So the examples that I showed you now We will learn more advanced concepts of those, and we will also learn generative design, data-driven design, and image-based voxel modeling systems. Okay. Apart from that, we also have the past webinars. So you can check our free webinars on our YouTube page. So the same YouTube channel in which we have this live webinar, you can see in the live section. Let me show you here. Okay, so you can follow these past webinars in a similar format. So you can download the files, you can follow step-by-step construction, and then we will see how to create textures in Grasshopper, and at the end how to render it in Keyshot. Okay, you also have further learning resources on how to create textures on bottles, or create textures on polysurface, or some interesting rendering workflows. Okay, the dates for all of our courses can be found here in the calendar tab. Okay, so these are live courses. I will be there in the class helping you out. You will follow along with me. You can share your screen if you have any doubts, and you can clear your doubts right away. Okay, so yeah, that's basically it. Thank you all for joining the workflow webinar 7.0. Yeah, let me know if you have any more questions, anything that you would like to add, anything that you would like to see in future. Awesome, thank you very much. Great, appreciate it. Matias, Fernando, Hamza, Giacomo, Brian. Appreciate it. Yeah, thank you very much. Thanks for the resources. Our pleasure. What's the difference between Keyshot Studio? It's just a newer version. The Keyshot that came in 2023 is called 2023, and from 2024 onwards they are creating a new type of subscription model, Keyshot Studio. Thank you for everything. I'm already looking forward to the next one. Great. You can also check the previous webinars meanwhile. Anything with Fusion? No, that's not our primary tool. We might maybe show you how you can use Fusion models and import it in Grasshopper to apply textures. But yeah, we can keep something like that. Learning surface creation and complex modeling. Could there be connection of the world of car design or similar? Our courses are tailored more for industrial design, not for automotive design. However, you will learn some foundation stuff which is applicable to any industry. So for example, what is a single span curve? What are these different continuity criterias? Okay, what happens when you trim a surface? How to create single span edges, how to split edges, etc. Okay, you will also learn some deformation tools which are amazing for creating complex shapes, kind of like by stretching, bending the geometry. Gargoyle, can I do it using the same method as this seminar? I don't know what is that, but Greeley and little simulation driven Greeley you may plan. Okay, yeah, you can. We do have a part in our texture course where we use Kangaroo plugin to create textures, and we kind of like drape a texture on top of this polysurface part. Okay, so we do have something in our advanced parametric texture workshop, but let me see if I can manage to fit it in one of our webinars. Yeah, you might have watched the triangle one, but there is one more that we cover in the texture workshop, because in the webinar one we don't cover the kangaroo workflow, but in the webinar one we actually drape the kangaroo simulation on top of the mouse. Could you please share the Autodesk alias link? Sure. Golden rules. I'm pasting it in the chat. How can I learn topology optimization? So you can find tutorials for the Topos plugin. That's the plugin that we use for topology optimization. Or you can check our computational design workshop. The next webinar, we don't know yet, but check our social media to be up to date. Does the Rhino course cover tolerance when it comes to fabrication, especially 3D printing? Yes, we cover tolerance. The part about 3D printing, we show you how to export models correctly so that you don't get those jagged faces, and how can you like shrink wrap everything into a solid model. But if you're talking about 3D printing lattice structures, like complex shapes fused together in a clean mesh, that is something we cover in the computational design workshop, okay, in this course. Okay, more for prototyping. Yeah, like for prototyping, yeah, you can probably use this one where we show you like how can you basically fuse everything into a single model and then just 3D print it easily. Okay, any more questions? Alias or Rhino for NURBS modeling? I mean, Rhino is 1,000 euros and Alias is, I think, somewhere between 10,000 to 30,000 euros. So, I mean, it's great, but depending upon your industry, depending upon if you have the resources or not, I like Rhino, so that's what I use. But yeah, it's up to personal preference. Okay, so I think with that said, we are going to stop here. Thank you all for joining. Do share your creations on social media, LinkedIn, Instagram, and do tag us. If you are interested in knowing what our past students think about our courses, you can check our Trustpilot page. And if you have any questions, feel free to reach out to us. You can directly write us on Instagram, LinkedIn, or to our email, info@academy. Okay? All right, so with that said, thank you all for joining. Good luck with your project and with your work, and see you guys soon in the next webinar. All right? Perfect, guys. Thank you very much. Take care.